All right, so now we're going to look at example 13. The following studies show association. Do they show causation? What are the lactine confounders and how would you adjust for them? Smoking and liver cancer. Studies have shown that smokers have a higher rate of liver cancer. Now that seems weird. Smoking and liver cancer, how are those related? Usually smoking and lung cancer are related. So how are we getting to liver cancer? What is the other thing that connects those two together? Can you think of anything? What happens to people who usually smoke a lot? Do we know? They also tendencies, of course, this isn't everybody, but people who tend to have smoke a lot also tend to drink a lot. And so drinking affects your liver. And so the thing that actually ties those two together is alcohol consumption. So alcohol is the confounding variable. Because drinkers again, this is tendencies. And when we're talking about things like this, we are usually looking at overall tendencies, not something that could be abnormal. Not everybody who drinks also smokes, that's true. But what we're looking at is overall tendencies. All right, for B, buckle up campaign and seatbelt use. Seatbelt use goes up 5% after the buckle up campaign starts. So do you think that the only factor involved in having seatbelt use go up was from this campaign? Anybody else know anything else that started at the same time as this campaign? Well, what happened was it also became a law. Seatbelt law went into effect, and so now if you're not wearing your seatbelt, you can get a ticket for it. Okay, so that's really probably not just the campaign itself, but most likely now there's a penalty for not doing it. Okay, so the seatbelt law was enacted so this may be the confounder. Most likely it's not just due to the campaign. Usually there's going to be some sort of penalty that really encourages people to change. All right, the difference between lurking and confounding variables. So here's a couple of things to look at. Two variables are confounded when you can't tell which one of them or whether it's the combination had an effect. So you might want to test a fertilizer on your lawn. Suppose you spread it on half the lawn to see if the grass will look better there. If you spread it on the sunny half, leaving the shady half unfertilized, you won't know whether the greener grass resulted from the fertilizer or from the sunshine or both of them together. Okay, you have too many factors going on to determine that it was just the fertilizer that influenced the growth of the lawn. Okay, versus a lurking variable is sometimes referred to as a common response. It's a variable that drives two other variables, creating the impression of an association between them. So for countries, pick any measure of technology, so usually like number of TVs per capita, and life expectancy. And you can also look at cell phones or computers or anything like that. You'll clearly see an association. Countries with fewer TVs have lower life expectancy. Okay, and so usually the opposite's true. So the countries with more TVs have a higher life expectancy. And really, such lurking variables as general economic well-being and standard of living probably explain the relationship there. We don't actually think that having a TV increases your lifespan. What's happening is if you can afford to buy a TV or some other measure of technology, usually you can afford to go to the doctor and have medicine and those types of things that are going to prolong your life. Okay, so that's kind of the difference with lurking variable is there's something else that's tying them together that's not usually in your study. versus confounding, usually the two factors are in the study and what's happening is you can't tell the difference between them. Okay, so here's another example of confounding. When Carter was a baby and we were trying to get him onto baby food, and you're trying to find out what they're allergic to, if they're allergic to anything. So what they tell you is to, when you try a new baby food, don't try anything else new for like 5 days. Okay, so if you try something new, just keep that in their system. Don't add anything else that's new, so that you would know if he's allergic to it. Okay, so if you tried 2 new foods, on the same day, he turns out he has an allergic reaction. You don't know now which one he was allergic to or whether it was the combination. So that's why they tell you to spread it out. So just do one at a time, so you would know if he's allergic to that one, and then start another one after he's shown that he has no reaction to it. So again, confounding is just that you can't tell the difference between what's influencing or affecting the study. Right, experiments allow us to study specific factors that we are interested in while controlling for the effects of lurking variables. And experiments can give good evidence for causation. Okay, observational studies, not usually showing causation. It's usually experiments that we're able to get some cause and effect relationship between those two. Okay, so example 14. Do smaller classes in elementary school really benefit students in areas such as scores on standardized tests, staying in school, and going to college? The Tennessee STAR program took 6,385 students who were beginning kindergarten and assigned each one to one of the following 3 classes. Regular class, 25 to 30 students with 1 teacher. Regular class with a teacher and an aide, and a small class, which was 13 to 17 students. The students stayed in the same type of class for 4 years, then all returned to regular classes in later years. Students with the small class had higher scores on standardized tests, were less likely to fail a grade, had a better high school grades, and so on. Is this an observational study or an experiment? And if it's an experiment, what are the factors and how many treatments are there? Okay, so first off, is this situation observational or an experiment? Okay, observational, again, is that we have no control over what's happening. And an experiment is that we're assigning students or people or whoever into different treatment groups. Okay, so here they assigned them to 3 different types of classes. This didn't just happen by accident, so this is going to be an experiment. Okay. So if it's an experiment, what are the factors and how many treatments are there? The factors are basically the variable that we're looking at. So if this is an experiment, what was the different factors that were affecting things? Okay, the thing that they put into 3 different types was the class size. Okay, so we have a regular class with 1 teacher, a regular class with a teacher and an aide, and then a small class. Okay, so the class size, or I guess the ratio, is what, if you want to think about it, the ratio of teacher to student is really what's affecting things. So here, how many treatments were there? How many different groups did we assign people to? There are 3 factors. Okay, we had the 3 different classes are the 3 different factors. So we end up with a regular class, with 1 teacher, a regular class with a teacher and an aide, and then the small class. So these are our 3 different factors. Oh, I'm sorry. These are really the 3 different treatments. there's only one factor, class size. The three treatments are the three different class sizes. Sorry about that. So one factor, the class size, we're going to break it down into basically three different treatments. Regular class with a teacher and aide, and small class. I'm sorry. Okay, and then, for example, 15. A coffee lover decided to investigate which brand and strength of coffee a random sample of people liked. The researcher decided to compare Starbucks and Peet's coffee. They brewed the two different brands using half a scoop, a full scoop, and 1.5 scoops of each of the types. So Starbucks got a half scoop, a full scoop, and then 1.5, and then they did the same for Peet's. So complete a table to illustrate the factors, levels, and treatments. So first off, we have the coffee type. We have two different types. And so we are just going to make a table here. So we have Starbucks and Peet's. Usually people are very particular about their coffee. I don't actually drink coffee, so I don't really know. But I have heard that Peet's is stronger, and usually everybody has a preference on one or the other. Okay. So these are the two different types, and then we're going to look at, we gave different strengths, different amounts of the coffee. Okay, so the different scoops. So the strengths that we have are half a scoop. We do that for both. We can do a 1 full scoop, and then 1.5. Okay. So I'm just going to label these. So we're going to do this each for Starbucks and Peet's. So Starbucks with a half a scoop, Starbucks with a full scoop, and Starbucks with 1.5. I do the same thing for Peet's, just using a Peet. So Peet's with half a scoop, Peet's with 1 full scoop, and Peet's with 1.5. Okay, so that's just a table to illustrate what we have going on here. So what are the factors in the experiment? The factors are usually the variables. So what are the variables that we're looking into? It's not the specific amounts, it's the overall variables. So what we're looking at are, the factors are going to be the coffee type. Okay, that's the variable, and then we have Starbucks or Peet's are the options, but the variable is the coffee type, and the other one is the strength. And then we have 3 different strengths, but the variable that we're considering is the strength. What are the levels in the experiment? So those are the different, within the variable, so within coffee type, what are the different levels that we're going to be looking at?